Assalamu alaikum everyone. I hope everyone is well. So this is a continuation of the previous video where I proved two circle theorems. So in this video I'm going to go through a few some more circle theorem problems and how I approach to solving these problems. So don't forget to watch till the end and let's jump straight into with the calculator intro. So if you look at the circle theorem problem, it says that prove that the angles in the same segment are equal. So it's basically saying that this arc that creates the angle, this angle and this angle with these 2 points and these 2 points, these two angles are equal. You have to prove that. So I've done a rough drawing in the note, this exact drawing. So you can see this arc creates these two angles. So you have to prove that these two angles, so let's say if this angle is A, this angle will also be A. So you have to prove that. So let's say this is the center O, and if we add these 2 points, let's say these 2 points are B and C, and this is the center. So this angle is the central angle that is created through the arc BC. So if we look closely, if we assume that this angle is X and this arc BC also creates these two angles at this circumference 2 points, these 2 points, let's say these 2 points are X and Y. So as we know from the previous theorem that the central angle will be double the amount of this angle and this angle. So if this is X, this is X by 2, and this is also an angle in the circumference created by this arc. So this angle is also X by 2. So these two angles are equal. So the second problem that we are encountering is you have to prove that the opposite angles of a cyclic quadrilateral sums to 180 degrees. So this is a quadrilateral within a circle. So you have to prove that the opposite angles, this angle and this angle, the sum of these two angles, or this angle and this angle, the sum of these two angles is 180 degree. So if I go to the notepad, I've done a rough drawing here. Let's say this is a quadrilateral within a circle, and let's say this is the center, which is O. So you have to prove that this angle and this angle's sum, the sum of these two angles or the sum of these two angles is 180 degree. So let's say these points in the circumferences, let's say these points are A, B, C and D. So if I add the circle center O with each of these points A, B, C, D, or let me just draw this like this, and this is, let's say like this, and this is, so I've drawn the center O with each of the 4 vertices of the quadrilateral within the circle. As you can see, all of them, OC is a radius, OD is a radius, OB is a radius, and OA is also a radius. So we know that if within this triangle ACO, within the context of triangle ACO, the angle, because these two are equal, they are radius, so the opposite of this, which is this angle and this angle, these two angles are equal. These two angles are equal. We did a previous video where we showed that if this angle, let's say this angle is X, so what will be this angle and this angle? both will be what? 180 minus x by 2, because the three angles in a triangle, if they sum up to 180 degree. So in the context of ACO, if this is x, then this angle is 180 minus x by 2. So similarly, in the context of triangle COD or CDO, however you name it, in the context of triangle CDO, if this angle is, let's say this angle is y, so it will be, because these two are radiuses, they are equal, so the opposite angle, this angle and this angle will be same. So if this angle is y, then this angle and this angle will both be what? 180 minus y by 2. Similarly, if we look at the context of triangle DBO or DOB, DBO, in the context of triangle DBO, radius, this is radius and this is also radius, so the opposite angle, this angle and this angle is equal. So if this angle, let's say this angle is Z, so if this angle is Z, then what will be these two angles? 180 minus Z by 2. And now if we look at the context of triangle AOB, in the context of triangle AOB, in the context of triangle AOB, let's say this angle, because this is x, this is y and this is z, this would be what? This angle would be, because all of them sum up to 360, the last angle would be 360 minus x minus y minus z. So if you use the same formula that we did in the last 3 occasions for the 3 different triangles, in the case of triangle AOB, this will be what? These two angles, if this angle is 360 minus x minus y minus z, these two angles, because they are equal, they will be what? 180 minus this angle, which is 360 minus x minus y minus z. So 360 minus x minus y minus z, this by 2. So these two angles are 180 minus 360 minus x minus y minus z by 2. So we know all these angles in the expressions of x, y, z. So we have to prove that this total angle, or the sum of these two angles, this angle and this angle, and the sum of these two angles, this angle and this angle, is 180. That's going to be enough. So if we add these four angles, so what is this angle?
180 minus x by 2. So 180 minus x by 2
plus, what is this angle? 180 minus y by 2.
180 minus y by 2
Plus this angle, which is what? 180 minus z by 2.
180 minus z by 2
Plus this angle, which is what? 180
minus 360 minus x minus y minus z, 360 minus x minus y minus z by 2.
Now we can simplify this, because we can do some simplification here. So if we take out the bracket, it will be 180 minus 360 plus x
plus y plus z. So it can be written as x plus y plus z, and 180 minus 360 is minus 180 by 2. It will be 180 minus x plus 180 minus y plus 180 minus z.
plus this term, which can be represented as this also, which is x plus y plus z minus x plus y plus z minus 180. So if we simplify this term more, we can get what? This is minus x, this is plus x, this is minus y, this is plus y, this is minus z, this is plus z, and this is plus 180, this is minus 180. So what is left? 180 and 180, which is 360 by 2, which is 180. So the sum of this whole angle and this whole angle is 180 degree. You can similarly prove that the sum of these four angles is 180. The result will be the same. So this is how you can prove that in a quadrilateral that is inside a circle, the opposite angles sum is 180. So if you look at the next problem, it says that prove the alternate segment theorem. So the likely question is, what is an alternate segment theorem? So if you go to a website, the thirdspace-learning.com, you can Google it, what is an alternate segment theorem, and you can check the first link where I went. So what is an alternate segment theorem? So the alternate segment theorem is the angle that lies between a tangent, this angle, this is the tangent, and this is the angle, and this is the chord AC, tangent and the chord. So this is the chord and this is the tangent, the angle that lies between the chord and the tangent. This angle is equal to the angle subtended. So this chord in any point, let's say point B, subtends an angle that is theta. So this, you have to prove that this angle theta is the same as this angle. So this is the alternate segment theorem. So if I go to a notepad, I did a rough drawing of this. So as you can see, this is the chord in question. Let's say this chord is AB, and this chord creates an angle with the tangent. Let's say the tangent is T. The tangent, this chord, this angle, you have to prove that this angle is equal to the angle that chord AB creates in the alternate segment, this angle. So let's say this point is C. So you have to prove that this angle and this angle is equal. So let's say the center is O. So if we join A, B, C, these 3 points in the circumference with O, let's say this is CO, this is AO, and this is BO. So these are all radiuses, R, R, and R. So these are all radiuses. So let's say this angle is X. So because they are radius, the opposite angles are equal. So this angle and this angle are equal, which we did in the previous 2 videos. So if this angle is X, what are these 2 angles? 180 minus X by 2. So let's say this angle is Y. So similarly, what are these 2 angles? 180 minus Y by 2. And similarly, if this is X and this is Y, then this is what? 360 minus X minus y. So what are these two angles? These two angles are 180 minus this angle, which is 360 minus x minus y by 2. So this can be simplified as what? 180 minus 360 plus x plus y. So x plus y minus 180 by 2. So you have to prove that this angle, this whole angle, or the sum of this angle and this angle is the same as this angle. So if we sum, we know that these two angles in terms of x and y. So we can write this angle is what? X plus y minus 180, and this angle is 180 minus x by 2. So this whole angle is 180 minus x by 2, 180 minus x by 2 plus this is 180 minus x by 2, and this is x plus y minus 180 by 2. X plus y minus 180 by 2. So this whole angle is the sum of these two terms. So these two terms, if we simplify this, it is 2 and 180. This is 2.
180 minus x plus y minus x plus y minus 180.
So this is what? Y 180 is gone. So there is only y by 2. So the sum of these two or the whole angle is expressed as y by 2. So if you look at this angle, we know that this angle is
180 minus y by 2. So 180 minus y by 2.
And this is the radius. So the radius to a tangent is supposed to be 90 degree, because this is the tangent. So the tangent is perpendicular to the radius. This is of course a rough drawing, but this tangent whole angle, this angle is supposed to be 90 degree, because it is a tangent and this is a radius. So and this angle is 180. This angle is 180 minus y by 2. So what is this angle? 90, the whole thing, minus this. So we get this. So 90 minus 180 minus y by 2. This can be simplified as,
it is 2, 180 minus 180 plus y by 2. So if we cut off this, we get y by 2.
so as you can see, both have the same expressions for all values of y. This will have the same value. This angle is equal to this angle. So we have proved the alternate segment theorem of the angle that lies between a tangent and a chord is equal to the angle that lies between the tangent and the chord. This chord is equal to the angle subtended by the same chord. This chord subtends this angle. So these two angles are equal. So you have proved that. In this video and the previous one, I showed how you can solve circle theorem problems, and I showed you how I approach to solving these problems, and hopefully it helps you to figure out how you can approach or how you can take an approach to solving circle theorem problems. So in the next video, I'll come up with another set of topics. So stay tuned for that.